Hello everyone. In this video we will be seeing how to generate object code for the following SIC program, and using this object code how to write the object program for this SIC program. This is in a assembly language and we are going to generate the corresponding object program for this program. So we'll start with the first statement. The first statement says sum start 0. This says that sum is the name of the program and it is going to start at the location 0. What does this mean? The location counter starts from 0000. Since the location counter table is represented, the entries are represented in hexadecimal format, we are going to write 0000. But why are we going to write zeros over here and not here? Because we see this last statement, end first, it says that we are going to end the first executable statement. Correct? FIRST is the first executable statement. That is the meaning of this statement. So hence we are going to start it at this location. The program starts at this location. So moving on to the next statement, it is first clear X. Correct? What does this statement say? This is clearly a format to instruction. Format to instruction because we have used registers over here. We used a register and this is the opcode, and there is no second register mentioned, and hence we can take it as 0. So this is a opcode and this is a register. It occupies 8 bits and 4 bits for the first register and 4 bits for the next register. This is how format 2 is represented. We will see how to generate object code for this later. Before that, we'll just fill up all these entries. Okay, so it says that it is a 2 byte instruction. It is because of this being format 2 instruction. So 2 bytes it is. So we are going to add that to this location counter table, and the next value will be 0002. Okay, so next let's see the next statement, that is LDA #0. This statement clearly is a format 3 instruction statement, and hence it occupies 3 bytes, and hence we add up 3 bytes to this location and it forms 0005. Okay, so next statement is plus LDB #total. So clearly it is a format 4 instruction because there is plus mentioned over here. It is a format 4 instruction and it occupies 4 bytes. That is why we have written 4 over here. Okay, we are going to add 4 bytes to this, and this will form the next instruction, or the next statement will start at the location 0009, because we are going to add this 4 bytes to that. But why haven't we written anything over here is because this statement base total says that this total is a variable that is using the base register, base counter. Okay, so the value of total is the value of the base register. Okay, so this is an assembly directive and hence there is no need for us to specify in our memory location. So the next statement starts at this location 000, adding up 5 to 4 will form 9. Looking into this statement, which says loop add table comma x, is a format 3 instruction and it occupies 3 bytes, and hence we are going to add 3 bytes to this value, which will form 000c. Okay, the next statement is tix count. Clearly this is also a format 3 instruction and hence 3 bytes it occupies, and adding that to this forms 000f. And this also is a format 3 instruction and hence 3 bytes it occupies, adding that to this f forms 0012. This as well is a format 3 instruction, STA total, and hence 3 bytes it occupies, and hence if we add it to this value 0012 forms 0015. Okay, and over here this is a statement that says that we are going to reserve one word for this variable. One word is equal to 3 consecutive bytes. Correct? That means 3 bytes. So this also occupies 3 bytes. So it adding up to this value forms 0015 plus 3 is 0018. Okay. This is a variable of type word. This is a word which occupies these many number of bytes. Okay, but this representation is in the form of decimal and we have to convert it into hexadecimal representation. So, well, after converting it, it forms this 2000. When it is converted to hexadecimal representation, forms 1770. How we are going to get? We are going to divide this value by 16 and the remainder what we get is used to calculate the hexadecimal value. The calculation I hope you people know, that is I will not be doing. So the value obtained after conversion is 1770. Okay, so that we are going to write over here. It occupies 1770 bytes of memory and hence the next statement starts at this location 0018 plus this value will form 1788. So the next statement, that is total RESW, will start at this location and this variable is a word that occupies 1 word. Okay, so we are reserving 1 word for this variable. 1 word is equal to 3 bytes, correct? So we are going to write 3 and hence we are going to add it to this value. So it is 178B. For the last, there is no need to calculate or look up. It doesn't occupy any memory. This thing in the location counter table, so there is no need for us to calculate further. This specifies that this is the end of the program and first is the first executable statement. That's it. Okay, so our program ends at this location 178B. It starts from 0000 and ends at this location 178B. Okay, so these are all the values for the mnemonics given. This is all given in our question. Okay, these values are already been given. Using these values, now what we are going to do? We are going to generate object code. So let us see how to generate object code for each statement. The first statement is first clear X, correct? See, first clear X is the first statement. It starts at this line. Okay, it starts from the second line. So I have written 2 over here. First clear X. Okay, let's see how to generate object code for that. This is a format 2 instruction, correct? It's a format 2 instruction and the clear value for clear is already being given. It is B4. How do we represent it in the bit format? B means what? B means 11, correct? So what is the value for B? 8, 0, 1, 1, 8, 9, 10, 11. What is the value for 4? 0, 1, 0, 0. This is the bit representation in the form of bits, correct? So this occupies the format, in the format 2, opcode occupies 8 bits. So we are going to take all these 8 bits for representation. Hence, how do we represent it in our object code? We are going to represent it in this way. This is the opcode and this occupies first register and this occupies second register. I just write it over here. Opcode, register 1, register 2, and this occupies 8 bits. This occupies 4 and this also occupies 4 bits. So what is the opcode value for clear? 10110100. And what is the value for R1? What is R1 over here? R1 is X. X is the indexed register. So what is the value? These are all default values. For X it is always 1 and for A it is always 0. Okay, what is the value for X? It is 1. How is it represented in bits format? 0, 0, 0, 1. Okay, so write it over here. And R2 is not been given. Let us take it as 0. Nothing is there. So how do we generate the object code now? We are going to take these 4 bits, these 4, these 4. So it is going to be B410. So what is the object code? Object code clearly is B410. Okay, that is what we are going to write over here. B410 is the object code for this first statement. Let us See now the second statement, LDA hash 10. It is starting at this location and it is the line number. Okay, LDA hash 10. What is the opcode value for LDA? It is already been given, that is 00. So LDA means 00. How is it represented in bits? In this way. Since it is a format 3 instruction, right? So we will be taking the first 6 bits. Correct. So how do we represent it in our object code format? In the format 3 representation, opcode occupies 6 bits and NIXBPE. These are the flags, correct? And this is the space for our displacement. It occupies 12 bits and all these flags occupies 1 bit each. So what is the opcode value? 1 2 3 4 1 2. This is the opcode value, and this statement clearly says, because there is hash present over here, it says that it is using an immediate addressing mode, and hence the value for I will be 1, and it is not indirect, that is why 0. It is not indexed, doesn't use base relative counter, program counter. It is not a format 4 instruction. Okay, so all this is 0. And what is displacement? Displacement clearly is the immediate value, that is 0 itself. That is why we are going to write, and since it occupies 12 bits, we are going to fill up zeros with that. Okay, so how do we generate the object code now? We are going to group 4 bits together, each 4 consecutive 4 bits, and hence it will be 0 1 0 0 0 0. The object code now clearly is 0 1 0 0 0 0. Okay, so we got the object code for this statement. 0 1 0 0 0 0. This is the object code. We'll move on to the next statement starting from line 4, plus LDB hash total. Okay, so since there is plus over here, it is a format 4 instruction. Okay, what is the value for LDB? What is the value for this mnemonic LDB? It is 68. Okay, mnemonic value is 68. How do we represent it in bit format? For 6 it is 0110, for 8 it is 111, 1000. So we are going to take first 6 bits. Correct, first 6 bits, because opcode occupies 6 bits in format 4, and hence we'll represent it over here like this. This is the space for opcode. It occupies 6 bits, so it is going to be 011 0 1 0 1 2 3 4 5 6. Okay, now this is the place for storing our flags NIXBPE, and this is for address. Correct, NIXBPE, and this is neither indirect nor immediate. This is not indexed. It doesn't use program counter. Okay, and what is it using? It is using program. It doesn't use base register. It neither uses program counter, and hence it is going to be 0. Yeah, why is it not using any of these counters? Is because it is a immediate addressing mode. There is hash over here, and that's why we have to write I as 1 and N as 0. It is not indirect, correct? That is why. That means it is using an immediate addressing mode. That's why I is set to 1, N is set to 0, and it is not using any of these counters, and it is a format 4 instruction. That is why E is set to 1. And clearly we have to just specify the address of this location of this statement. So it occupies 20 bits in format 4. And where is total located? Total is located in this address, in this location. See, total is located in this location 1788. Okay, so the address of total this format 4 is 1788, but since it occupies 16 bits, there are 4 numbers digits, it occupies 16 bits, but over here it is 20 bits. So we are going to fill it up with zeros initially, and we are going to write the corresponding bits representation. Okay, in bits representation we are going to write the value for 1788. For 1 it is 0001, for 7 it is 0111, for 8 it is 1000, 1000. Got it? 1778 I have represented in bits format. That is what I am saying. Okay, so now we will generate the object code. We are going to group consecutive 4 bits together to form the object code. So this is what? This is going to be 6, this is 8 and 1, 9, this is 1, 0, 1, 7, 7, 8. What is the object code? Object code now is 69101778. So this we are going to fill it up in our entry for this location. It is 69101778. Okay, this is how we are going to generate object code for each statement. And what is this statement? Base total. That means the base register also is saved with the value that is there for total. Okay, what is the value that is there for total? The value for total is 1778. That is why the base register also occupies this value. It contains 1778. The B value contains 1778. That is the meaning of this statement. Okay, so moving on to the next statement, it is loop add table comma x. So let's take that statement over here. It is a format 3 instruction, correct? Format 3 instruction, and for add, the add mnemonic, the value opcode value is 18. So for add it is 18. How do we generate how do we represent it in bits? In this way, correct? We are going to take first 6 bits. It is a format 3 instruction. And hence it occupies 000110, 6 bits, correct? Opcode. And the flags NIX BPE. This is the field for displacement. What is this? It is neither indirect nor immediate. It is indexed address. It is using indexed addressing mode. That is why x is set to 1, and it is not using the base counter. It uses program counter, and it is not a format 3 instruction. And now we have to calculate the displacement. Displacement, what is it? Displacement is equal to target counter minus program counter value, right? This is a formula. What is the target address? Target address for table we have to see. What is the target address for table? Target address is 0018, right? So we are going to write 0018 minus, what is the program counter value? It is always the location, which is location of the next executable statement. What is the next executable statement after this statement? It is 000C. It starts at 000C, right? That is what we are going to write over here. Okay, so we are going to subtract this with this. So the value will be 000C, hexadecimal subtraction. Okay, this is the displacement value that we are going to represent it in 12 bits. Since it occupies 12 bits, we are going to take the last 3 bits, 3 digits, hexadecimal digits, and that we will take to represent for 00C. C is 12, right? It is represented in this way. Okay, now we are going to group it together to calculate the object code. This is 1, 8, 9, 10, 11. 11 means B. This is 8, 9, 10. A. 0, 0, C. So clearly the object code for this statement is 1B A 00 C. Okay. So we will be writing that in our table whatever we have formed. So we are going to write it over here, correct? It is for add table X 1BA 00C. 1BA 00C. Let us take the next statement. TIX count starts at the location. The number is 0 and it is starting at this location 000C. So I want to take the next statement. TIX count. The opcode value, before that this is a format 3 instruction, right? Let us write format 3. The opcode value for TIX, where is TIX? It's over here. The opcode value is 2C. How are we representing it? 00101100. Take the first 6 bits. Okay, it is a format 3 instruction. So this is how we represent 001011 6 bits. NIX BPE. This is for displacement. This is for displacement and it occupies 12 bits. Okay, so let us see what are the entries for these flags. So this TIX count is neither indirect nor immediate. It is not a indexed addressing mode statement. It doesn't use a base register. It uses program counter, and this is not a format 3 instruction. Now we have to calculate the displacement. Displacement is equal to target address minus program counter value. What is the target address for TIX count? What is the target address for count? Count starts over here. This is the target address 0015. What is the program counter value? Program counter value is the entry of the next executable instruction where it starts with. This is the statement. The next executable instruction is 000F, right? We are going to write that over here. Clear? So now we are going to subtract it. The value we get is 0006. Hexadecimal subtraction. So that is the displacement value now. That we are going to enter it over here. We are taking the last 3 digits 0000, 0000, and for 6 it is 0110. So group it together. What is the value for this? For this it is 2. This is F. This is 2, 0, 0 and 6. The object code now for this instruction, this statement is 2F2006. Correct? So we are going to write that over here, 2F2006, the object code. Next, JLT loop. JLT loop is the next statement. This is also a format 3 instruction. And what is the opcode value for JLT? The opcode value for JLT is 38. So 38, how is it represented? 0, 0, 1, 1, 1, 0, 0, 0. Take the first 6 bits. Opcode is 001110, right? This is the opcode. NIX BPE, and this is displacement. It occupies 12 bits. Okay, so this clearly is neither a indirect nor immediate instruction, addressing mode instruction, and it is not using indexed addressing mode. It is not using base counter, it uses program counter, and this is not a format 4 instruction. Now we have to calculate the displacement. Displacement is again target address minus program counter value. What is the target address for this loop? Loop starts over here, and the address is 0009, correct? So we want to write 0009 minus program counter value for this statement. This statement's program counter value is 0012, correct? So we are going to write over here, and we have this forms -9, okay? -9, we have to represent it in 2's complement. In the SIC XC programs, the negative value is represented using 2's complement, and if we calculate, we will get this as the value FF7, okay? That is the method for calculating 2's complement. I have explained it in the class. Please refer that, okay? So we are going to write the corresponding bits value in the displacement field. So it is going to be F. For the next F it is this one, and for 7 it is 0111, correct? So now we are going to generate object code. It is 3, 8, 9, 10, 11, B. It is 2, F, F7. Now the object code for this statement is 3B2, F, F7. That we are going to write 3B2, F, F7. Okay, moving on to the next statement, STA total. STA total is a format 3 instruction. And what is the opcode value for STA? It is 0C. 0C. How are we going to represent? We are going to represent it in this way, like the first 6 bits, and represent it in its format 2, 3, 4, 1, 1. This is for N, I, X, B, P, E. This is displacement, okay? So over here where we see that it is neither indirect nor immediate. It is not indexed addressing mode, and total uses base counter. That is what we saw over here, correct? So we are using base counter over here, and we are not using program counter. It is not a format 4 instruction, okay? So now we have to calculate displacement. What is the formula for that? Target address minus base counter value, correct? What is the target address for total? Total's target address is 1788. 1788. And what is the value for base in the base register? I had told, right? The base register value is the value of total. That is what is mentioned over here, correct? So what is the base register value? It is 1778, right? That is what we are going to write over here, 1778. That is why it is 0. Always the displacement will be 0 when we are using base counter. That is what this implies, okay? So just enter 12 bits, sorry. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4 for 0. Now we are going to group it together to generate the object code. It is 0, F, 4, 1, 2, 3, 0. So what is the object code for this statement? Object code for this statement is 0F4000. Correct? We are going to write it down. 0F4000. Okay, that we have written. Now just look over here. This is not a format, any type of format instruction. This is it just says that this variable occupies these many number of bytes. It is of type word that occupies this many number of bytes. One word means 3 bytes it occupies. That's all. So there is no need to generate object code for these corresponding statements. Okay, so this ends the generation of object code. Using these object codes, we are going to generate object program. Correct? Object program we will be generating. How do we generate that? See, it is always represented using these records: header record, text record, end record. These are the basic records using which the object code will be generated. Okay, so first is the header record. So how many it is denoted by H. H says that it is a header record and it occupies one or it is present in first column, and from the column 2 to column 7, this is the program name. Column 2 to 7, program name is sum. Correct? I had told earlier the name of the program, sum. Since it occupies only 3 entries in the column, 3 columns, the next 3 columns will be left blank, and hence it starts off from here is what is the meaning of this blank. Okay, and this denotation is just for our reference. In actual object program, there is nothing as such mentioned. Okay, what is the next column? Next column starts from 8, column 8 to column 13. Okay, starts from 8. Okay, what is this? This is the starting address of object program. What is the starting address? Starting address is 0000, right? But it occupies 6 entries from column 8 to column 13. That means 6 entries. That is why we are going to fill it up with another 2 zeros. Okay, what is the next column? The next column is from 14, column 14 to column 19. What does it say? It says the length of object program in bytes. Okay, length of object program. How do we generate the length of object program? That is equal to the last address minus the starting address. Correct? The last address minus the starting address. What is the last address? Last address we saw, correct? Last address is 178B. Last address is 178B. Starting address is 0. Correct? So we are going to calculate like this. That is equal to 178B. Correct? This is the length. That is what we have mentioned over here, and to fill it up we have added 2 zeros. And the next record is the text record. Text record, so it is denoted by the letter T, and then starts from second column. The column 2 to column 7 states that it is the starting address for the object program in this text record. In this text record, this is the starting address. So the starting address obviously is 0000, right? That is what we have written over here. And for this object or for this program, we will be taking up all the entries. Okay, since there are only few entries, we will be denoting it using only one text record. If there were more object codes, then we can use more text records. Okay, so it starts from 0. And what is the next column saying? From column 8 to column 9, it says the length of object code. What is the length of object code? See over here, from column, that means from the line 2 to line 9, we are taking the object code. Correct? So till here 0 1. What is that? The last entry in the location counter minus the first entry. That means 0012 minus 0000. It was 0012, but it occupies only 2 columns, column 8 and column 9. So we will be taking the last 2 entries, that is 1 2. Got it? So let us see the next column. Then the next column starts from column 10 to column 69. Okay, how much ever entries is possible till the column 69, those many number of entries we can write for one text record. That is the meaning of that. And what it contains? It contains the object code that is represented in hexadecimal format. Okay, so all the corresponding object codes that we had obtained after our calculation, those object codes will be entered over here. See, this is like this. Okay, B410, 10, this one 0100, all that will be, since there was no place over here, I have written over here. That's all. So till here, this is the text record, and it occupies this much length of the object code, 12 bytes. And what is the next record? It is the end record. It is denoted by the letter E, and Next column says that column 2 to column 7, it says the address of first executable instruction. What is the address of first executable instruction? First and first, right? It is 0000, correct? First. So that is what we are going to mention over here. Since it occupies 6 entries, that's 6 columns, so we are going to fill it up with 2 zeros. This is how we are going to generate object program for the corresponding SIC program. I hope it is clear for all of you. Thanks for watching.